Of course, most of you are here to find out what a Klein Bottle Rubik's Cube looks like. So here straight away are 3 different views of the same Klein Bottle Rubik's Cube in the last stages of being solved. Pretty mysterious, but I'll explain. Now, this Klein Bottle Rubik's Cube is just one of hundreds of different Rubik's Cube-like puzzles in MagicTile, an amazing piece of software by Royce Nelson. And it's completely free, so get your copy. Link is in the description. MagicTile contains some of the most difficult twisty puzzles you'll ever see, but also a lot of really nice easy ones that you can solve completely intuitively, so without looking up any sorts of algorithms. So today's video is an introduction to MagicTile, to this universe of puzzles, and some of the nice mathematics at the core of it. So what do these 2 patches here have to do with a Klein bottle? Well, it's really quite easy. You just take a square and bring the 2 red sides together, like so. That gives you a cylinder. Now the open ends we can bring together like that, and that will give us a donut, or in maths lingo, a torus. That's the standard way of bringing the 2 ends together. There's a non-standard way, and that goes like this. And you've got your Klein bottle. So really, when you look at a square, you are dealing with a flat Klein bottle. So as long as we specify how the 2 opposite sides are glued together. Well, with the red ones we already know they're glued together straight across. What about the yellow ones? Well, there, if you have a close look, it turns out they're identified with a twist. So just like a Möbius strip. So this thing actually does contain lots of Möbius strips. In other words, what we're dealing with here is a Pac-Man space. So there's little Pac-Man. As he hits one of the red sides, he re-enters right opposite. As he hits one of the yellow sides, he re-enters diagonally opposite, but also mirror reversed, which is very important. Remember that one when you're solving one of those Klein Bottle Rubik's Cubes and some pieces just don't seem to fit anywhere. This flat Klein bottle is actually the nicest Klein bottle there is. Much nicer than this one as far as mathematicians are concerned. Why? Because it's cut from a super nice surface, a flat plane. So what that means is that for a little Pac-Man that kind of floats around here, this guy here looks the same wherever he is. So the points are not distinguishable for a little Pac-Man. Unlike here. So when Pac-Man floats around inside the surface, he can actually do little experiments and distinguish between points. So one little experiment like this is draw a little triangle. Do it here, and you get not what you would expect, 180 degrees as the angle sum of this triangle, but you actually get something less than 180 degrees. On the other hand, if you draw a little triangle up there, you get more than 180 degrees. And that number will change as you move Pac-Man around inside the surface. Unlike here, you can draw little triangles wherever you want. The angle sum will always be 180 degrees, just like in the plane. And then, of course, now you know what it means for this to be a Klein Bottle Rubik's Cube. We can actually also bend this square together into a real Klein bottle, as I showed before, and then you get this guy here, which is actually also part of MagicTile, so you can actually solve this puzzle using that view too. It's a lot more complicated though, so most people would use that flat Klein bottle view. If you're a 4-dimensional alien or you have access to the 4th dimension, you can actually glue the sides of your square together so that the squares all stay square. So it actually stays super nice and you can play with this thing without open edges. So here's a view of our Klein Bottle Rubik's Cube. So we've got 9 square faces and we're turning around those faces. What about here? How do we turn there? Well, there's the turning circle. We know that things get glued together here, so the turning circle cuts into this part and really that part attaches here. And here we go diagonally across, and so this gray bit attaches here. And there's a little corner missing there. That comes from up there. Now let's turn. There you go. Now this extending business that we just produced just around here, we can actually extend all the way around, and that's something very useful. So let's just do it and actually extend all the way. What you're seeing here is the square tiling of the plane, colored in with 9 different colors. And whenever you see a red tile, you're actually looking at the same face. If you're focusing in on any 3x3 block, you get a different view of the Klein bottle. It's basically moving or turning the Klein Bottle Rubik's Cube around and viewing it from different sides when you moving this 3x3 block around. What about individual pieces? Well, we've got center pieces here and there. The center pieces don't move with respect to each other, both here and there, as we manipulate the cube. We've got corner pieces, 3 stickers here, 4 stickers there. We've got edge pieces, 2 stickers here, 2 stickers there. Now, with this guy here, we actually get one additional kind of piece, this Star Trek logo-like piece that also gets shuffled around. This is actually just one possible twisty puzzle that you can put on a Klein bottle. There's many, many more. So how do you get the other ones? Well, you can, for example, shrink that cutting circle here. When you do this, you actually only get 2 different kind of pieces. You get center pieces and these lens-like edge pieces. Or you can make the circles bigger. What that does is it destroys the centers here. And again, the turn behaves differently. But you can also move the circles so that they're centered at corners. You may be familiar with that principle. If you've got a Rubik's Cube collection, you probably have something like this. This is a Rex cube that also turns around corners. And if you've got a Rex cube, chances are you also have a helicopter cube. And with helicopter cubes, you turn around edges. And of course, you can do the same sort of thing here with your Klein Bottle Rubik's cubes. Other variations, you can actually change the number of faces that you're playing with. So this is a 6-face Klein Bottle Rubik's cube. Or here we've got 4 faces. In fact, you can do any number of faces. That looks just like what we looked at before, but it's actually different. So this turning is different from the one we saw before. Why? Because here we glue together across both in terms of the red sides and in terms of the yellow sides. So that's actually a flat torus Rubik's cube. And if you actually do this physically, you get this view here, which is also part of MagicTile, which you can also play around with. What we've looked at so far only accounts for 28 of the 811 puzzles in MagicTile at the moment. So what else is there? Well, lots more, and it's all based on tilings. So our Klein Bottle Rubik's Cube here, that's based on a square tiling of the plane that's colored in a special way. Now there's other tilings of the plane, other nice regular tilings of the planes. Actually, there's 2 more. There's one with regular hexagons, for example. So this one here. And there's a special kind of coloring of this tiling. And we've got the Rubik's Cube's cuts on top. And so when you have a close look at this, you'll find there's 9 colors here. And we get this patch. And when you have a close look, you see that the sides of the patch are glued together straight across this way and with a twist that way. So this gives us another kind of Klein Bottle Rubik's Cube. And actually for me, this is really the Klein Bottle Rubik's Cube. Lots of different variations, but which one is it? This is it. Everything you see here has a counterpart in the real Rubik's Cube. Right? So there's the center pieces, 1 sticker, edge pieces, 2 stickers, corner pieces, 3 stickers. So if you don't want to solve anything else and you're in for a challenge, you accept the Mathologer Klein Bottle challenge. So Royce and I agreed that there would be a limited edition Hall of Fame just for this video here. So what you can do is you can download the program, choose this puzzle, do a full scramble, solve it, save your log file, send it to Royce, and then he puts your name into the limited Hall of Fame. It's got space for 100 people. It's a fairly hard puzzle, especially since there's no ready-made solutions available for it. So you have to make them up yourself. If you don't know how to do this, check out that video there. But even for people who are kind of experienced in terms of making up the algorithms, you'll find lots of interesting stuff here that you won't find anywhere else. Okay, so check it out. Be interested in seeing how you go with this. So we've had regular tilings with hexagons, regular tilings with squares, and now we've also got these guys here, regular tilings with equilateral triangles, and all of these you can use to make up the Klein Bottle and Torus Rubik's Cubes. What I've talked about so far accounts for 1/3 of MagicTile. MagicTile also has the regular tilings of the sphere, and there's 5 of them, and they correspond to the 5 platonic solids. These tilings here are very different from the ones that we just looked at. Importantly, they only have finitely many tiles. This only has 4 tiles. This only has 8 tiles. And of course, with the cube, we won't got as many as there are faces, 6 tiles. So what we don't have to worry about to start with is coloring multiple faces here with the same color. We can just have one tile play the part of one face. And when you do this, you get all these sorts of puzzles. So that's the standard Rubik's Cube. That's Gigaminx. That's a Jinx Pyraminx. And those ones you can probably not find in shops. And there's, hundreds of them in MagicTile. We've covered 2/3 of MagicTile this way. Apart from the sphere and the plane, there's one more super geometry, which is the hyperbolic plane, which you can use for making up these puzzles. There are some incarnations of it here. So for example, this coral, that's closely part of a hyperbolic plane. That actually goes on forever, so it's kind of really hard to see what's going on. It gets more and more crinkly on the outside. It's not as obvious that this sort of thing should have the same property as the sphere, with the little Pac-Man kind of being able to slide around in here and not being able to distinguish where he is. But they have this property. And also in terms of tilings, the hyperbolic plane actually admits infinitely many different tilings. In fact, even better, you can just take any regular angle like an equilateral triangle and you can make up infinitely many regular tilings with this triangle, or infinitely many with a square, or infinitely many with a regular pentagon, and so on. These are a bit of a mess to look at. So how do we actually represent them in MagicTile? Well, there's nice pictures that are actually very symmetrical and that represent a lot more the symmetry and the niceness of this plane than the object itself. And so just like this is a nice picture of this tiling here, which is completely flat. That is a flat picture of a regular tiling with regular 7-gons. So of course, all these things look very different. So this looks like a regular 7-gon, but this one doesn't. Well, why? Because we've got a distorted view here. We've just got a picture of the real thing. But they're all regular 7-gons, and I actually can turn this thing around. So let's just turn it around. So if I rotate one of those other 7-gons into the middle, it actually will appear as a regular 7-gon. So all of these things are regular 7-gons. There's infinitely many of them. And I said that there's infinitely many tilings of this thing. Now this particular one is, of course, one of the special colored ones. So now we can turn this into a Rubik's Cube by putting in the cutting circles. We're using 24 colors here. Let's just isolate a patch. So when we glue this patch together, as the colors prescribe, we actually get this 3 torus, which with the special kind of tiling in the background is called a Klein Quadric. So this is a Klein Quadric Rubik's Cube. So also get that one and play with it. It's actually easier to solve than the Klein Bottle Rubik's Cube, mainly because of the absence of the twists. There's a lot more things I could talk about here in terms of the mats. There's orbifolds and there's projective planes and all kinds of other things. But I let you find this out for yourself. Now there will also be another video on Mathologer 2, in which I talk about MagicTile itself, the interface, how you program algorithms, how you find algorithms. And what I'll focus on in particular are the easiest types of MagicTile puzzles, and these are the Harlequin puzzles. These are edge-turning puzzles, so very, very nice puzzles, easy to solve. Check that out too if you're really keen. And that's it for today.